Good afternoon. Let's start today with our new lesson 8, machines. What are the machines? Machines, it's a device that makes work easier. So the objective of why we use the machines to make the work easier. I can apply less force with the same distance, or I apply the same force with this distance. So the machine make work easier. How it's make the work easier? By changing the size or the direction of a force. It could change the size or the direction. Size and direction. These are examples of some of everyday machines, like the chopstick, scissors, wheelchair. Why we use the scissors? To cut everything, because you change the direction of the force. So it makes easier for you, or it makes the work easier. The chopstick, the wheelchair. Here are an examples of
Teacher?
the machines. Yes, Rose.
Teacher, but like, what do you mean about changing size? Like, it will make the work easier if we change size.
Wait, I will give you examples. Okay. Wait, one by one. Now, the work that you do on a machine, we called it work input. So here, a system, we know that before that any system in our world, it has like, this is the system. Here in physics, our system is the machine. For any machine, we have something, we called it work input, and something we called it work output. Now, the work that you do on a machine, the work that you apply on a machine, we called it work input. And the work done by the machine, we called it work output. So in physics, to determine the efficiency of the machine, you have to divide the work output into the work input. If it is 100, we call it, this is an ideal machine, and this is like impossible to happen, because you cannot apply as an example, 20 joule, and the output will be 20 joule exactly. It could be 18, it could be 19, according to the friction, as an example, in the machine. So there's something we called it efficiency. The efficiency, it is the work output over the work input, and it is in percent. So sometimes when you say that the efficiency of this machine is 70%, that means if you add, or if you put 100 joule to the machine, there's 70 joule will be the output. So in the machine, or in any system in our world, we have something input and we have something output. In physics, in manufacturing, anything, you put, as an example, carrot with or sugar with lemon with mint, you have a juice. Because you have an operation that's happened in the machine, that's mixing them, you have now the output, which is the juice. Also here in physics. So the machines allow force to be applied over a greater distance. So I told you now, the machines make the work easier. What make the work easier? It's make the amount of the work is less than when I make it by my hand. So the machine here allow force to be applied over a greater distance. So the work is force over distance. So to make to make the work easier, you can do two things. You can apply, like if you have the work is 20. Okay, so that's mean either force, it could be 2. and the distance is 10. And you can say that the distance is 5 and the force is 4. So to make, if you want to make the same work, you can make it as a greater distance with less force, or you can make it a greater force with less distance. So here, so it means that if you want, or if you have the distance is 5, and you have to use the same work, my work is 20. I apply a force of 4 Newton over 5 meters. If I want now to apply the same work, but with a machine, how the machine can help me? It give me make the same work, but with a greater distance. Or you can say that it can.
You mean
also
it's like the same force, but we can push like a greater distance.
The same work with a greater distance. Or which means that also, so here, it's you have 5 meters, you can apply, or we can apply it with a greater distance, and look at the force here, it was 4, it will be 2.
Yeah, less force.
So less force with a greater distance, in both of them, you will have the same amount of work. This is the machines. It's allow you to apply the same amount of work over a greater distance and less force. How to make the work easier? By change the size and the direction. As later on we will see the examples. To make it easier, it can change the size of the force, as I did here. I change the size from 4 to 2, or the direction.
Oh, so teacher, the size you mean like the force, and the direction.
The size of the force, it means the magnitude of the force.
Yeah, okay.
Let's see now these examples here. Let's see how it's changed the size and the direction of the force. Look at the first example here. By your hand, this is the input force. You apply a force on the nutcracker. But when you cut the nuts, this is the output force. So here, the nutcracker is a machine. This machine can help me increase the force. Because imagine now you want to cut it by your hand. You will apply a greater force to cut it. But when you use this machine, this nutcracker, you will increase the force. Since it's increased the force, the distance will be short. Like we said before, here we have force times distance. So since it's increased the size or increase the magnitude of the force, we will have a shorter distance. Another example, look at the hammer here. For the hammer here, we have you knock on the wall. So this is the input force. And there's an output force, that's when the nail that's go inside the wall. Now, here, the hammer, it decreases the force. Imagine now you want to knock the nail by your hand. How great the force you apply. It will be very, very, very greater than if you use the hammer, because the hammer decreases the force. You will find sometimes that if you use the hammer, it will be easier for you to push or to push the nail inside the wall. So since the force is decreases here, the amount of the distance will be increased.
So teacher, here you mean about the hammer because like the more distance you will push it to the nail, the more less force will be, right?
Yeah, here, no, the opposite. It's mean you decrease the force because you use this machine, so you decrease the force. Since you decrease the force, you apply a greater distance. And in other words, also, sometimes imagine that when you try to use the hammer, when a greater distance, you put your hand farther away from the wall. Do you find
Then
that
it will be
the nail,
decreased.
yeah, you will decrease the force. So that's mean you will make it, and so the amount of work will be greater than if you apply a small distance because you push it
But
with
you
a
see, when
greater.
you make it like that, like you use a greater force because like you're making the hammer to go away, to push it more harder, right? Like it's not the distance also, it's also the force. Like, I mean, both of them will be increased because like when you push the hammer in a great distance with a great force.
A greater distance, I mean like you put it farther away from the wall.
And for the force, because you will decrease the nail.
You will decrease what?
The nail.
How decrease?
Because it will go inside.
How you decrease the nail?
Like, I mean, because you will push it with the hammer, so it will decrease the force.
Yes, I told you greater distance, you apply greater distance. So since you apply greater distance, you have less force. Or less force, that's mean greater distance. And
Okay.
you have the
Thank
same
you,
amount of work.
Okay, teacher, thank you.
Yeah. Now let's go to this example here. This is the screwdriver. In this case here, the one you have here, you have the lever. Inshallah, today we're going to talk about it. You have a lever. This is the lever. You have an input force. Or you have, this is the lever. You have like the seesaw. You have an input. You have here the output. This is the lever. Now, here you have a screwdriver. You want to open this can. So when you use it as a machine, or the lever as a machine, so you increase the force. Since you increase the force, so the distance will be decreased by applying the same amount of work. So for these three examples, for the nutcracker, for the hammer, and for the screwdriver, you change the size of force. How we change the direction of the force? By look at the pulley here. This is the pulley. The pulley, all of these, the hammer, the lever, the nutcracker, the pulley are machines. Some of them change the size and some of them change the direction. In our book, we are going to talk about the lever, which change the size, and the pulley, which change the direction of the force. Now, how will we see now how the machines change the direction of the force? Here, as you see, there's an input force. There's a pulley here. Each pulley, it has two rope like this. Now, we want now to, this is the input force, that's you are here. And you apply a force down. So where's the force now? You are applying it down. Or down, yeah, I mean downward. So since you apply it downward, the output force is not going to be downward, it's to be upward to make this rock or this stone going upward. So the direction of the input force is opposite the direction of the output force. The input is downward and the output is upward. So here the pulley change the direction of the input force, but the size will be the same. Is it clear?
Yes.
Yes. Are there different types of machines?
Sorry?
Like, are we going to study different types of machines, or we should just know what machines are?
No, we are going to talk about liver and pulley.
Okay.
Here you have 6 types of machines. But in our book, you are going to talk about machines and liver only, 2 types only. Liver as an example of changing the size of the force, and pulley as an example of changing the direction of the force.
We took pulley problems in the first semester, I remember.
Yeah. But here now we are going to talk them with finding the work. So here, for the nutcracker, for the hammer, for the screwdriver, as you see, we change the size of the force, but the direction will be the same. On the pulley, you change the direction of the force, but the size or the magnitude of the force in the input will be the same as on the output.
Teacher, it is like force equal force, but in opposite sides.
Yes. Now, this is here, as you see, this is the lever. And as we know, the work is the force times distance. And I told you, this is a lever, this is a machine. In the machine, there's a work input and there's a work output. Now, work input, to find it, you apply a force downward. So this is the input. You apply a small amount of force with a greater distance. But the output will be greater force with a small distance. But they are equal. So this is here a machine, there's a work input and there's a work output. The input force have a small amount with a greater force, which is equal greater force with a small distance. That's here how it's changed, or how it decreases the amount of distance, or how it's increased the amount of force. Now, so if you have here this numerical exam number here. Here now, as you see, we have a girl. The girl is push the seesaw or the lever downward with 10 Newton. So the amount of force here is 10. And the distance that is she apply the force is 1 meter. So the input here is 10 Newton times 1, which is 10. Now let's see how the output will be. The output, since now the distance will be 1/8 of the first one, it will be 1/8. So the force will be 80.
80.
So when you multiply them, you will have the same
10.
work. So here, as you see, we have a 10 Newton. You have a small amount of force, but when you use the machine, you can imagine now you have only applied 10 Newton of force with 1 meter. But with your 10 Newton, you can push, or you can hold a very, very heavy load with 80 Newton force. This is how to use the machine. Imagine now you have 1 kilogram object. With 1 kilogram, you can apply, or you can push an 8 kilogram force, or an 8 kilogram mass, sorry. Like how? By changing the distance. Changing the distance helped me to apply a greater force to hold the rock, even that its mass is 8 kilogram. So here, the work input is 10 joule and the work output is 10 joule. Is it clear?
But teacher,
How
is
do
it
you use
okay
the
if they are
machines?
both equal?
Now, yes, this is here. I told you how to use the machines. It makes them easier. It makes the work, I told you this is the machine, and in each machine you have a work input and you have a work output. For they make them equal, make them easier, you have to increase the force from 10 to be 80. But since the lever it's changed the size of the force, it will decrease the size of the distance.
Teacher,
Oh,
from
okay.
where did you bring the 80?
Here, the 80, that's mean since the work input and work output is the same. So, and since the rock from the distance from the rock to the land is 1/8 meter, and since they are equal, I mean like the work input 10 is 1/8 times the force output. So the force output will be 80 by multiplying
Teacher,
8 by each term. Yes, Habiba.
teacher, the input is the rock, right? And the force of the girl is the output.
Here you can say that the girl is pushing down the lever to make the rock going outside, to make up upward. This is the force. Look here. This is the applying force. This is the applying force. She pushed the lever downward to make the rock going upward. Who applied the force, the girl or the rock?
The girl.
The girl. But because here it's not moving, but the girl can apply the force to make the rocks moving.
Okay, thank you, teacher.
Yeah. Now, so here, after that, this is introduced now to find something we call it mechanical advantage. The mechanical advantage is a ratio of the output force to the input force. Mechanical advantage, or MA. Mechanical advantage. You can find it by two ways. You can say it is the output force over input force, or you can say also it is the input distance over the output distance. So the mechanical advantage you can find by two ways: output force to input, or input distance to output distance. Now be careful, this is different than the efficiency. The efficiency, it is the work output over the work input. Work output over work input. The mechanical advantage is the output force over the input force, not work by work, force by force, output over input. Or if you want to compare between them as a distance, you have to say input distance over output distance. So here, let's come back now to the girl here. For here now, what is the mechanical advantage? The mechanical advantage is the output force. Where's the output force?
It's 10 times 1.
It is 80 Newton.
Oh,
Where's the
yeah,
input
yeah.
force? It is 10.
10.
So that's mean the mechanical advantage here is 8. This is if you want to find it by output force over input force. And if you want to find it by the input distance, over the output distance, you have to say, what is the input distance? It is 1 meter. What is the output distance? It is 1 over 8.
1 over 8.
So it will be also 8. So the mechanical advantage is 8 here. Now, what is the unit of the mechanical advantage?
A Newton, right?
No,
They're not supposed to be any
Or is
units because
it's not. Yeah, it's
Because
not
Newton will
unit.
skip Newton, so there's no units.
So there's no unit here. The mechanical advantage is only a number because you can say it is a Newton over Newton and they cancel each other, or meter over meter and they cancel each other. And the efficiency, by the way, there's no unit for it. Is it clear?
Yes, teacher, thank you.
Yeah.
Now let's start with the type of machines here.
But teacher, about the efficiency, can you write the formula of it?
And this is just introduction. Inshallah, after this lesson, we are going to talk about the efficiency.
Okay. I think they are both similar, right?
To what?
Like
The same,
to each
yeah.
other.
That it
Yeah.
is. No, it is the. Oh, I told you it's the work output over work input. This is the.
Oh, okay.
Now let's now go to talk about the type of machines. We have 2 types. We are going to talk about them. Or we have 6 types of machines. 2 of them will be included with your book here: levers and the pulleys. What are the levers? The lever is a simple machine that has a bar that pivots at a fixed point called a fulcrum. Let's see what are the levers here. This is the levers. The components of the levers, that's you have a bar, and in the middle of the bar we have a pivot point. We call it fulcrum. This is the point, we call that fulcrum. So it is a machine that has the bar. There's a pivot point there's a pivot at a fixed point. We call it fulcrum. And for the lever, we have 3 types: first class, second class, and third class. Let's start today now with the first class lever. This is the first class. First class, it means the fulcrum or the pivot point is between the input force and the load. So here is the input force. And here is the output force. And here's the output force. Sorry. So here the fulcrum is between the input and the output, between the applied force and the load. This is, we call it first class lever. They are different. Okay, so be careful. The first class, here's the pivot point is between the input force and the output force, or between the input force and the load. Let's have an examples now.
Teacher, what does fulcrum mean?
This point here is the pivot point.
Oh, okay.
The fixed point. And as an example, wait a minute, please. Here we have an examples. Let's start them. We have the seesaw. This is the fulcrum here. It is the fixed point.
Okay.
Got it now? So I believe here we have 4 examples for the first class lever. The first one, which is the seesaw. The second one is the top of the hammer to get out the nails. Here you have an fixed point. Here you have an output, and here you have an input force. And also the oars. As you see
Teacher,
here,
where is the fixed
here's the
point in the
fulcrum.
hammer?
يلا wait. Here is the man. He applying an effort. This is the input force. This is the fulcrum, and this is the load. Here is the input force that he is applying weight. And here is the fulcrum or the pivot point. And here is the load or the output. The fulcrum here is between the input and the load. And the last example here, where's the scissors? Here also. In the scissor, wait please. In the scissors, here you have the fulcrum. This is the fixed point. Now, you apply a force by putting your fingers in the scissor, and the load will be this one here. You apply, the load will be, that's the output force will be used to cut the paper. Now, let's come back now to the hammer here. To the hammer here, where's the output force? Is it my hand? Or is it when I push or get out the nail? The output force.
No, when you push the nail.
Pick up the nail.
Get out the nail. So this is the output force. Because I used the hammer to put out the nails. Now where's the pivot point? Now imagine it now here. You have this hammer here. You put it and you try now to push out the nail. So where's the pivot point?
Is it
The
between
point
the
that is
nail
not
and
moving.
the hammer?
The point that is not moving. Which point? The point that is fixed. This one here. Did you imagine now what he did? What did he do? How did you push the, we have a hammer at fixed point and you try to move it upward. Like now here, put your hand on the table and push your fingers up. 2 fingers, try to pushing them up. This is the output force. Now where's the fixed point or the fulcrum? It will be this point. The point that is at the pivot, between the output and the input, which is fixed, we call it the pivot point or the fulcrum. And here is the input force. Flat applying from your hand. Is it clear?
Yeah.
Yeah.
So these are the examples of the first level. What is the first level? The first level for the lever, that's mean here the fulcrum is between the input and the output force. Between the input and the output. And examples such as seesaw, top of the hammer, oars, and scissors. Now, tomorrow we are going to talk about the mechanical advantage for the first class. And also we are going to talk about the second class level. What is the second class? Examples of it and the mechanical advantage of the second class, and also the third class and the mechanical advantage of it and an example of it. And inshallah next week we are going to talk about the pulleys. Is there any question?
No, teacher, my the second math quiz